today we will do simulation on common emitter configuration of BJT. For this, we will select the component first. We are selecting the a transistor, so we will write NPN transistor. Option will come. We will select one of the transistor. Suppose we selected this transistor, this one, silicon NPN low power bipolar junction transistor, 625 milliwatt. It can operate up to 625 milliwatt, 150 degrees centigrade. So this power consumption is also given, and we are selecting. You can select this one also. We are selecting this one, 5%. So we have placed it here, and now we have to plot. Suppose we are going to plot output characteristic. Output characteristic is a plot of IC, output current, versus VCE. So we are going to plot this. For different IB, we will plot this. For different base current, we will plot IC versus VCE versus IC graph. So VCE will E and IC on y-axis. So for this, what we will require? We will require a source to bias it. So we are going to the generator, a DC source. We are selected. Placing a DC source, connecting it, and this one. Now input side we are selecting DC. Since our source is input side, we are plotting IC versus VCE for different IB. So here IB edit properties, we are selecting it as a current source. For different current, we will plot. So we are placing it as a current source. You can name it as IB. So this one. Now this voltage I am naming, I am writing it as VCE. So okay. Now place a ground. Emitter is connected to ground. This one. So we have connected it to ground. Now we have to plot. So for this plot, we will go to this graph. We will place a transfer. Select the transfer and place the graph here. This way. Now one more thing. We have to plot IC for these two sources. VCE, changing VCE, and for different IB. So we will take a current probe. We have to measure IC for different VCE and for change the input side for different IB. VC versus IC for different IB. This is our objective. So whatever you want to measure, just place a probe here. You can rotate it this way, and now you can write the name as this is IC, which we are going to plot for different VCE. So now you can drag it and drop it to the graph. Now place right click, right click, and you can edit properties, and you will see the options. We are plotting one thing is we for different IB. This way. So in this way we obtain the, you can see, for this is changing VCE x-axis, one of the source, and for different IB, these are the plot. For IB1, IB2, IB3, IB4, for different IB, IC versus VCE. As we know, as we increase by VCE, the reverse VCE NPN collector based junction is reverse bias. So almost all the current reach to the collector. All the current from the emitter, all the injected electrons from the emitter reaches to the collector. That's why it becomes almost constant. So this region is called active region. This region is called saturation, and when the current is very low, almost zero, it is called cutoff. So in this way, we simulated the NPN transistors output characteristic. If you want to plot the input characteristic also, just take one more graph. Now we want to plot input characteristic, that is a graph between VBE and IB. So for this, our source, we are selecting the source as a voltage source VBE. This is not a current source this time. Yes, because this is our source, and probe. We want to, which plot we want? We want IB plot. So we will select a probe. Go to the select and probe and a current probe. Place it here. Okay. So this way we have placed. You can name it as edit properties. You can name it as IB. Okay. So now our source is VBE. That is, with reference to VBE, with the change in VBE, we will obtain the plot of IB. So we will go on the graph and we will edit properties. Our root is, source is VBE. This time only one source. Okay. And drag this. We want to plot IB. Just drag it. Select and drag it here. Now simulate the graph. This way. So this is our input characteristic. VB, why we selected it as a DC source? Because in the simulation, this is the source. Our voltage is the source. We want to plot IB with respect to voltage. So we selected the voltage, and you can see as around 0.6, 0.7 volt, 0.1 volt is this, below 1 volt, here around 5, 6, 7. It is almost on, and now as you increase VB, just like a normal diode, IB increases. So thus we plotted both input and output characteristics.